Okay, today, yes. School days, not weekend days. Weekend days is like less than 2 weeks. Okay. Now, today we're doing histograms, and what Dylan said earlier, it's the history of all the data. Really, really easy. Okay. I do histograms all the time in my research class. When I talk about different data and test scores. Huh? No, yeah, I am, but I'm already done with the other one. It's all math. So, all this is telling you the history of the graph. This is not a line graph. This is kind of a bar graph, but it's extra. Okay? So here's what we need to do. First, we got to figure out, let's do the second one here, where it says complete the frequency table. Later. We'll talk. So here, we're going to go into the second example. A histogram shows the history of the graph, and it shows all the data. Okay? So what we need to do is we need to organize it. I'm going to show you how to do this. It's really simple. The heights in inches of 25 students. We're going to use this tally, this table here, to figure out how many times it comes up. So for example, see where it says 70? Yeah. They put a mark here, so I don't need 70. 72 has already been used. 59, 1 at 59. 56, 55, 60. Dylan, let's go. 48. It won't be easier this summer. 59, 48, 66, 72, 58, 60, 60, 50, 68, 72, 68, 62, 62, 72, 58, 58, 60, 68, 59. Yes, so confusing. Now, I hope you got the same answers I did. Did you get 4? Yeah. 4. 4, 5, 7, 1. Excellent. Stop. 1 and 2. Now, we're not graphing every single number. We cannot do that. There's no room on here. So a histogram, the histogram looks at the frequency. So you're only looking at this number and the intervals. This is the only two that matters. The frequency is the number of times it shows up. They're frequent. How frequent? How often? I'm sorry, what? All right. Now, on the first one, what was the highest number of frequency? 7. Yeah. So 7, right? So I would need, let's start with 1 then. 1, 2, 3, 4, 5, 6, 7, 8. 1 through 8. Sir. What do you need? I'll figure it out. It's outside already. So here, on the first one, 45 through 49. You make a box. Chris, let's go. How many occurred at 45 to 49? 2. Only 2. Only 2. We are not graphing every number. You can't. There's no room for it. We're only graphing the frequency, the intervals. The next one, 50 to 54. How many occurred?
1.
1. 55 to 60. 55 to 60.
7.
Oh, sorry, not 60. 59, right? Sorry. 7. all the way up, all the way over, 7. I like to put the number in the box so I know how many to graph. It keeps me from making a mistake. 60 to 64. 5. 65 to 69. 4. Sorry, it's going to go off a little bit. And the last one, 70, 74. 6. Okay. Questions on the graph so far? We're just making kind of large, connected bar graphs. The history. Now, what happens if I did this?
Then you covered it up.
I covered it up. But what did I cover up? The table and the answers, kind of, right? So by looking at this, can I say that I have two 45s?
Yeah.
You sure? Can I say that I have two 45s or two 49s or two 47s? How about, can I say I have 170 and four 74s? No, why not? What does a histogram not tell you?
The exact number.
Louder?
Amount.
Louder?
The number of each number.
It does not tell you the exact amount.
The number of each number.
It does not tell you how many times the number came up. That is the difference between a bar graph and a line graph and histogram. A histogram does not tell you the number of times, unless you have this table, right? But if you don't, then you just have to go off of what you know here. There was 2 here, and there's 1 here, there's 7 here, there's 5 here, there's 4 here, 1 here, and 6 here. That's all you know, right? So, but can I tell you, or can you tell me how many people were above 60? Can I say, how many people are more than 60? More than 60.
15.
How many?
16.
What? 16 or 15?
15.
How would you know that? Right, you just add up all the groups up, right? More than 60? Histograms do not tell you the exact number. They just tell you the history, just like an overall general. It can tell you, oh, I only have 2 people in this category or this category. That's why when you do surveys, what do they ask you in those surveys? What are they asking in those surveys? Just a random survey. Supermarket or a receipt, almost receipts that you get?
Yeah, ask you what you like.
But more general. What's your opinion? Besides your name, phone number, email address.
Oh, I was at Jason's Deli on Saturday, and the survey said if you call, if you have a smartphone, you call the number, and they asked, like, what was your favorite thing?
Before that, don't they ask you about your age?
Phone number.
No.
So you all say between 18 and 36, 18 and 49, between 26 and 35, and well, why would they ask that question? What are they trying to do? How are they marketing it?
Make a graph. Old or young.
Who's buying my stuff? Who's eating the food? Old people or young people? If I have a lot of old people eating my food, like soup and salad, well, they will market it towards the old people because people are coming in between 65 and 70 years old, right? Probably they will market it for the pricing, so they'll make all the specials like at 4 o'clock in the afternoon. Early bird special, right? Talking about how they market people. So, but they may see that all the people that are coming into the store or the restaurant are young, right? They're all between 18 and 25 years old. Well, they're going to, I don't know,
At night.
make it later at night. People are with, families and stuff, or people on a date or whatever. They will make it more for that people. That's why they have histograms. They're showing groups of people. That's how they do. That's how they do Super Bowl commercials, people. They know that people, usually men, watch the Super Bowl, right? And they're younger. So all the commercials, all the really, remember that kissy one?
Oh, yeah.
Yeah, it was at the very beginning. That was at the very beginning of the Super Bowl, right? That was at the very beginning because they knew that everyone's going to be watching at the very beginning. The majority of the young people will be watching in the beginning, right? And then when Beyonce sang, all those commercials in between, all the women were watching. So all those commercials are all for women. That's how they do advertising. They use histograms to show we know that women between 25 and 36 will be watching between when Beyonce goes on. All the men will be out of the room. Right? So when the game starts again, guess what? All the commercials were for men.
Well, you remember whenever Janet Jackson did the Super Bowl?
I do. I was in college. All right.
Did you watch it?
Yes, of course. It was really awkward. All right. That's why they do time delay. It's always a 1 minute time delay. All those live shows, it's a delay. There's a 45 second to 1 minute delay. So what you see on TV is not actually live. It's actually a tape delay. So in case something happens on live television, they can stop it. They can delete it in the control room, and then play it in 1 minute. Oh, they can fix a lot of things in 1 minute. All right. People, television is really interesting. They use histograms all the time.
How did it show the Super Bowl? Remember Janet Jackson?
That's what happened. They fixed it after that.
Okay, but what about the power out?
That was pretty cool.
I'm really hungry.
All right. I know, me too. All right. Go ahead and do the second one, please. Where it says average high temperature in April.
That's my birthday. That's my birthday.
Hey, her birthday, April 4th.
April Fools? Yeah.
April 4th.
She made me learn it last year.
4/4?
4499.
I'm old.
It's my birthday.
I know how. Okay. Let's go. All right. Really easy. Put the temperatures from least to greatest. Actually, you know what? Do you have to, though? They kind of tell you already, right? So then 87. So I would put like a mark right here. Shh, ladies. 67, mark for this one. 54, 79, 56, 63, 51, 81, 60, 68, 73, 51. All right, that wasn't difficult, right? So then all I have to do is make a box. 4. Keep going. 4, 2, 2. That's it. Now, again, if you did not have this telling you what it was, histograms cannot tell you the exact amount. They group the data in groups. They put them in groups. Okay? But if you did, you would know. I've only been to London, Toronto, Rome, Paris. No, I want to go there one day. I'm going to Thailand, so yeah, we'll probably go to Thailand. Yeah, we'll go to China in November. I want to go to Australia. That looks pretty cool. Go swim in the Great Barrier Reef. It's very dangerous. It's all like rocks.
Have you heard the song called Montreal?
Montreal. It's a French city in Canada.
Montreal on the weekend.
Should I? I'll find on the thing. Okay. So, students, let's go to the next page here. I do want to talk about correlation because guess what? I just learned it last week. So I feel like I can teach this even better. Talk to her later.
What time is it?
Time for you to get a watch. Now, ooh, yes. Here's my, this is the data I use to, like this is what I do for my homework. So I use correlations all the time, and I make these really pretty little graphs like this for my research. Isn't that cool?
No.
And I get these things I have to know how to read. So a correlation, well, like I'll teach you what a correlation is, college style. Why? Because you need to know. Okay, you ready? Let me give you a college lesson. Me on the range. Here we go. When you are in a relationship, right? It's you and another person, right? You and another person, right? A relationship, you know, could be good or bad or whatever. It could be positive. It could be negative. It could be nothing at all, right? What? No, nothing. Now, a relationship is one thing, but a correlation, company, cooperation. The prefix co means together. How do these numbers relate together? Are they positive together? Are they negative together? Are they no relationship? What does a positive correlation mean? Who's getting along in terms of math? More specifically.
Even.
Same numbers, even out.
In math,
The X and Y.
the x and y's they get along. They're positive. They get along with each other, right? So if they're both positive numbers, what's happening to those dots?
They're getting higher.
Yeah, it's positive.
You already got.
It's up to you. But look how closely they are. Look how close they are. They're positive. It's a positive correlation. They're tight together. It's positive, right? The more you study, the better you do. Usually.
Oh.
Right?
Then,
Right? The more you exercise, the more weight you lose. It's positive. In math, the x and y's are positive. They go with each other. They're both positive. But when they're negative,
Go down.
what's going down?
The numbers.
The number.
When you don't exercise, you get fat.
Ooh.
Well, that's also a positive correlation. Well, it could be both. We'll talk. A negative correlation, that goes down.
That's when they're all scattered.
That's like kind of when a person's going through a breakup. Like one person's happy, one person's the one goes, it's not you, it's me, kind of thing.
Yeah.
You know, that means the kind of the relationship's going down to the ground. In math, the x is decreasing, y is increasing, but the x is decreasing. X is saying it's not you, it's me, kind of thing.
So no arrow.
It has an arrow, but this is going down, right? One person's not happy.
No arrow. Arrow going down.
Yeah, it's going down to the ground. It's negative. They're sad. What happens if there's no relationship?
They don't know each other.
Well, go back to science. Go back to a gas.
Carbon monoxide.
Think about the molecules. How are they arranged?
Noble gas.
They're all spread out. Like when you fart, all the gas spreads out. It's the same thing here too. You can't contain it. There's no relationship. These are just random people in a room.
So we're
Singles party, yeah.
So we're no correlation.
No correlation. There's no relationship. It's like right now, there's no relationship. Just random people in a room. Right?
Yeah, me and him.
He and I.
Black power.
He and I. Okay, don't do that. So, the line of best fits. The line of best fits is the line that kind of goes, it kind of tells you positive or negative. And no correlation, I can't draw a line. There's no relationship. Right? There's no relationship. Everyone's kind of random. Okay? So the trend is really positive and negative trend. This is a college level topic right here. I just learned this last week.
But why are we learning it if we're not?
Because this is the beginning of Algebra 1.
We're not.
You're fixing to be. Alright, I understand. Number 1, the number of pages you read in a book and the number of pages you have left. The number of pages you are reading in a book, the number of pages you have left. How does that work? What's happening when you flip the page?
You read, and then the stuff you haven't read it yet, so
Okay.
you're going to read it later.
So it's going to be positive or negative. If I'm flipping through a book, right? Let's say if I have a book, right?
Yeah.
And it's on page 100. As I read over time, what's happening?
It gets smaller.
What's getting smaller?
Increasing. The pages are increasing.
But think about the number of pages you have left.
But the number of pages you already read is decreasing.
Decreasing, right? So eventually you're going to be at 0. That is a negative.
Why would it be an increase? Because the number
Because
of
you're not
pages
adding
you
more.
read.
Because you're not adding more pages to it.
You're adding more pages to the pages you read.
I understand, but think about it. The more you read, if I have 100 pages left, as I read over time, I have no pages left.
Well,
You're
you have-
adding
well, you
more
have-
pages to other stuff.
I know, but you're thinking too hard.
Okay, but
Think about the number of pages you have and the number of pages you have left.
And
the remaining pages.
Because I already read those, and I only want to hear them.
This is for-
Remaining pages, son.
Or if you read those books that are from right to left.
Like in China?
But you know, from right to left.
China.
These books,
Japanese books. Any Asian book. then it will be the other way around. Yes. Yes. Shh. All right. The day of the month
Okay.
and the wind speed.
No correlation.
Man, it was windy yesterday. It was crazy windy. It was like 30 miles an hour.
Yeah.
See the wind? Did you see the weather on the news?
I can hear it. I can hear it outside.
Yeah, I heard it. It was crazy.
Yesterday was the perfect weather to find night.
It was. Yeah, unless you want to fly away too. So, is there a relationship between the day of the month and the wind speed? This is no relationship. No correlation. No relationship. The age of the car and the selling price. Just think a regular car. Nothing fancy. Not the vintage ones. Just a regular car. Not that. Just like a Chevrolet or Toyota or something.
Corvette.
So the moment you buy the car, right? You buy it at You buy it at a certain price. You drop the lot. It's completely used. So it'll be if you buy here for this amount of money over time, it decreases in price or a negative correlation. That's why for me, I lease my cars just because I like to drive a new car every 2 years. And if I have to buy a car, Jeremiah, I buy a demo car. DEMO. You know what demo stands for?
Demo, like whenever you
You go test drive a car,
try
right? You try it out. Those are brand new cars, right? But when they sell it, the dealership sells it at the used car price, even though it's a new car. So you get it for almost 20-30% off.
My uncle drives a new car that he shipped.
Those are that's a lot of money too. All right, let's do a few more here. All right, this is a tricky one, and don't disappoint me because I'm going to tell your history teacher. Number 7, the population of a state and the number of senators, not representatives.
That's no correlation.
Senators.
Yeah, that's no correlation.
It's not a correlation.
How many senators are there?
Because it depends
Per
on how-
state.
It depends on how many people are in the state.
Depends on how big
2
the
per
state is.
state, right? Does it matter how large or how small?
No.
No. This will be no correlation. But if it had said representatives, how many representatives are there in the House Rep?
It depends how big your state is.
What's the total right now?
527.
No, a little bit less.
500.
430,
38.
435. I've actually been there. I'll show you pictures. I'll have a chance. It's really neat. Okay. Did you learn? I hope you learned something today because I like to learn stuff. Histograms, correlations. My goal every day for you is to learn something new. Anything new. I don't want to waste your time because you don't learn anything and wasting your time. Thursday?
Hudson Jackson.
Yeah, I should be. Well, it's on round left though. Yes. All right. Have a seat, sir. All right. On this one, before we leave, because the bell's gonna ring. Have a seat. All right. On this one, students. All right. On this one right here on the top, remember that the frequency goes here. Go by 2s. I'm sorry. Go by 2s here on number 1. Tori. Go by 2s on the side. On number 2, go by 2s again. Go by 2s. 0, 2, 4, 6. On number 2, go by 2s on the side. And then number 3, go by 2s again. What number goes on the side here? 2. Okay? So tomorrow's homework should look like this. Okay? So look at that. Yes, on the back page. On the back page, all you're doing is you're reading this graph and putting the graph on this line. Okay? So put these numbers on this line. Anything else? Have a good day. Say goodbye, YouTube.
See ya. See ya. See ya.